Okay, so here we are with graphing sine and cosine curves. From the first couple of pages of the note sheets that we've done the last couple of days, we've generated a lot of general information. We've got a feel for the period, which is how long it takes for the graph to do its thing. That's the phrase I've been using. Standard sine, standard cosine, it's going to take 2 pi, which again just represents one trip around the circle. For the graph, for example, the sine to start at 0, go up to a y value of 1, which corresponds to this point, get back to 0, which corresponds to pi, get back to get down to -1, which is down here, and then back to 0, which happens over here. And that's just going to continue to repeat that process over and over and over again. Just in general, we said the sine curves kind of starts at the middle on its axis. Obviously, it starts at the origin. Cosine, however, starts at its max. And again, that's because on the right side of the circle, when you're at 0 radians, the cosine value is 1. It's measuring that width right there, which is 1. And so it starts there. By the time it gets to the top, your triangle has no width, so you're 0. Then over here on the left side, that width is -1, so it's down there. And then back down to here at 3 pi over 2, the triangle has 0 width, so it's at 0 again. And then lastly back to 2 pi, where it started at 0. Again, has a y value of 1, or an area or the width of your triangle is 1. So these two major concepts, you can read them for yourself, they're huge. We're going to continue to use those basically for everything that we do with graphing, which is going to be for, say, the next week or so. So now we looked at some how we can kind of mess with the sine curve by giving it some transformations. Horizontal, which is stuff that would occur inside the parentheses, and vertical, which occurs outside the parentheses. Same stuff that we did earlier with basic polynomial functions, square root functions, logarithmic functions, exponential functions, all that stuff. The big players, though, the main two are b, the number inside that's being multiplied by x, which is going to affect the period, how long it takes to do its thing, and a, which affects the max and min values, the vertical component of the graph, how high it goes and how low it goes. We talked about that a lot today, and we figured, a is very straightforward. The positive value of a is going to give you your max. The negative value of a is going to give you your minimum y value. The b value is a little more subtle. We developed this formula today that the b value is going to determine the period according to the formula 2 pi over b. So the period of a sine or a cosine graph is 2 pi over b. That is certainly a major concept. 2 pi over b equals the period. So we did two basic examples in class. One was a cosine and one was a sine. We did exactly two periods of both. We used the a value of 0.5 and the b value of 3. Generated our tick marks across the x-axis, generated our tick marks up and down the y-axis, and then just basically outlined max, middle, min, middle, max for the basic template of a cosine curve. So it's pretty straightforward. Where we're going from that, though, is to add a little bit more challenge, and that's what I'm going to work on right now, which is when you have h's and k's involved. So, we did the second example. Again, it was a sine curve. Basic, though, just had an a value of 10 and a b value of 2 pi over 9. Numbers across the x-axis a little bit funky, but nothing we can't handle. And, of course, a, again, letting us know where our max and minimum values are. So this is where we left off with this example, -2 sine of 3x plus pi over 2. So the very, very, very first thing we did was we realized it did not meet our template. Our template has to have the b value factored out so that we can recognize what h is primarily. So the way we're going to attack this is first get that factored out, get that 3 factored out. The resulting term, of course, back here, h is what's going to turn into pi over 6. Pi over 2 divided by 3 is pi over 6. Now, in class, I think I had that as minus negative pi over 6, so you could see the template and compare it to a sine of b x minus h plus k. And we were saying, a plus pi over 6 is like minus negative pi over 6. But as far as I'm concerned, identifying that h value, if you just say it's pi over 6 and you recognize that inside the parentheses gives you when it's plus inside the parentheses, it's going to mean you're going to shift it left. I'm happy if you just say pi over 6 to the left for h. You don't have to worry about putting a positive or negative there, just to kind of remind yourself you're going to be shifting to the left pi over 6. Meanwhile, we had already identified our a value as -2, our b value is 3, and the b value of 3 will lead us to our period, which of course is going to be 2 pi over 3. I'm sorry, I'm going to write 2 pi over b, which is equal to 2 pi over 3. And a quarter of that period is a quarter of 2 pi over 3, which gives you pi over 6. So what that did was it let us know that the end of our first period would be out here at 2 pi over 3, and 1/4 of it is pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. That's where we get those, and of course I did it in the negative direction as well. And that's about as far as we got in class. Now, the one thing we have to address is this k value, which is +1. So what that's going to do is shift our graph up 1 unit. So I guess I could make a note that k is 1, so we put it on the record, earn some partial credit that way. And essentially what that's going to do is give us sort of like a new x-axis. The entire sinusoid is going to be shifted up 1 unit. And so that dotted red line is going to be this kind of our new axis for the curve, or what I've been calling the mid. So if we're looking about a sine curve here, this thing could go, because a value is -2, the fact that it's a 2 there tells us that we're basically going to go up 2 and down 2 and up 2 and down 2. But we're going up 2 and down 2 from a spot of 1. So that's going to take us up to 3 and down to -1. Up to 3 and down to -1. Up to 3 and down to -1. So I think maybe I guess also in red, I'll come across, oh no, I can go green here. I'm going to go green. Oh no, I'm not going to go green. I thought I chose green. There we go. So let's do that. All right, let's use green here. Come across. And that's going to sort of show us the top of our curve. And then 2 units down from 1 will be the bottom of our curve. So our curve is going to exist between -1 and 3. It's not necessary to do that, but I think as we get started here, it's probably a good idea. So I can switch back to the blue now, and we're going to be ready to go to kind of start putting some points on this thing. Now the clutch thing here is that we're dealing with both an h and a k value, h being pi over 6 to the left and the k value being 1. So whereas our sine curve normally starts at the origin, we're going to be shifted pi over 6 to the left and up 1 unit. So this spot right here is sort of like our new origin. So if we consider it that way, we can just put a nice big old fat dot right there as our new starting point. And we learned today that the important stuff, the maxes and the axis points and the mins, happen at 1/4 intervals through the period. All we have to do now is think, okay, well, because we have a negative sign, a -2 sign, that's going to provide a reflection kind of across our horizontal axis. It's going to take all the things that were positive and make them negative, all the things that were negative and make them positive. So because our sine curve normally starts and goes up, this negative sign is going to make it so that our sine curve starts and goes down. So here we go. I'm going to put our next point where I went over a quarter of a period and I went down 1 unit. Then from there, we're going to cruise up, and we're going to get back to our axis at pi over 6 on the positive side. So get our second dot there. Then we're going to have to hit our max up here, and then we're back to our middle. So if I connect those dots, they're reasonably good looking sine curve. Wow, that's getting really ugly. Let's try that again. There we go. There we go. So, for those of you counting along at home, what we've just done is drawn 1 period. And some of you might be saying, well, wait a minute. We didn't go out to 2 pi over 3. That was our period, was 2 pi over 3. Well, no, we didn't make it out to 2 pi over 3 because we started a quarter of a period back. But you can see we have 1, 2, 3, 4 quarters of our period, so we've got our whole period. Just we went from negative pi over 6 to positive pi over 2. So this horizontal distance is what our period is. So our period is still, that's a total distance of 2 pi over 3. Unfortunately, our directions rather, ask us to graph 2 periods of our function. Well, this becomes kind of a joke now because all we have to do is extend 4 more quarters of our period. So we could do, if we wanted, maybe one more to the right here. So I could say come out down there to that point. So there's 1 quarter. And then I could hit maybe 3 quarters to our left. Move over here, we're going to be up there, and we're going to get that quarter. So now we have 2 extra quarters. We're going to be back to our middle where we have 3 extra quarters. And then lastly, we're going to get our 4th extra quarter. So now we have 2 full periods. And I think that should be pretty clear to you that we are essentially seeing a period here in this distance because our graph did its thing, started at the bottom, went up, hit the max, came down, hit the bottom. So it went through all of its values there, and then it started again and went through all its values. So that's exactly 2 periods. You can think of this and this, this green distance here being 1 period. So there you go. It's really not that tough. The one thing I would add to this, if it was on a test or a quiz, is go through and at every single one of these points, I'd go through and label the coordinates. So I'll just do a couple just to show you what I'd be expecting there. So for example, this guy right here would be negative pi over 2, comma 1. This guy up here would be negative pi over 3, comma 3. Parentheses around that, and so forth, and do that for each of those. What do we have there? 9 points. So that's it. It's not too bad. The next page is going to get a little bit more interesting. Actually, just double thinking that. I think I'm gonna end this one video right there, where we've got a nice kind of stopping point. I'll make it so that you can maybe come back and check this out. The next part of it, which I'm going to do on that next slide, as a separate viewing, because this one now we're probably going on 10, 12 minutes. That's probably enough for right now. But again, you would certainly see something about this level of difficulty, maybe even a little bit more, with some funkier numbers here across the x-axis. On a test or a quiz. Notice, though, I was very nice, and we shifted our function exactly a quarter of a period. That is sort of my trademark. I will generally shift it a quarter left or a quarter right. But there you go. So that's a good intro into how you start with a sine or a cosine curve with all of its shifts, left and right, up and down, stretches and shrinks, and you're good to go. So look for part 2 of sine and cosine graphing as a separate video.